Good afternoon. Welcome to the presentation of the GeoSpace III group. We've had 5 students with us this year who have been studying geology at Lake Miva, and tomorrow we're doing the second part of our geology training. And 4 of the 5 students are going to give you presentations now on topics in space that they are enthusiastic about. And I'm very excited to hear them tell their stories. So the first off is Sophia Crowder.
Good afternoon. For those of you that don't know me, my name is Sophia Crowder. I'm 17 years old and I'm from the United States, and I serve as a student ambassador for higher orbits as well as a NASA space grant scholar. Now, before I jump into why space inspires me and why space explorations inspires me, I'd actually like to share a little tidbit and a little story about myself. Growing up, space wasn't my first passion. It was actually dinosaurs. Growing up, I would always ask myself, where did the dinosaurs go? Why can't I see them in zoos? Why aren't they here in person? And so this led to me discovering my love for space because I learned about the asteroids and meteorites that came down and took out the dinosaurs, unfortunately. And so this led me to this incredible program called Go for Launch with Higher Orbits. Higher Orbits is an educational, nonprofit outreach program that aspires to inspire the next generation of future space explorers, scientists, technologists, engineers, and mathematicians using the wonders of space flight and space science. And so at my first Go for Launch, I got to meet my very first astronaut, Mr. Don Thomas, who I'll talk a little bit more about later. And my team and I designed this contraption. So we were tasked with this goal of how to create art in microgravity. And so over the course of 3 days, working with our astronaut mentor, Mr. Don Thomas, my team and I, called the Pisces Project, designed this device that, from the black little motor you see there, would send these balls of ink to this spinning contraption in the middle that would fling them all around and hit the 4 different canvases on each side of the payload, creating abstract art similar to Jackson Pollock in microgravity. And so this was my first little adventure into space exploration, space science, and it's still awaiting its launch to go into microgravity and to actually function, but this is where my passion for space was really solidified, and I knew that this is something that I want to pursue with my life and what I do. And so I loved my first Go for Launch so much that I begged my parents to take me another one closer to my home state of Virginia in Washington, D.C. And this one was sponsored by the American Institute of Astronautics and Aeronautics, and it was hosted at the Lockheed Martin headquarters. And so here's some pictures of me and my team. And so at this event, we were tasked with designing a science experiment that could be done in suborbital flight. And so my team and I researched tardigrades. Tardigrades are extremophiles. They can survive in some of the most extreme conditions, extreme heat, without water, without food, in microgravity and radiation. And so my team and I designed this experiment that would send up tardigrades in various stages of their life. Some as eggs, some as already full-grown adults, and we wanted to study their indestructible properties. And so we wanted to see how we could apply that to the future of space exploration. And so this kind of segues really well into me being a NASA scholar. So later in that same year, I was appointed as a NASA scholar through the Virginia Space Grant Consortium, and using this same idea of tardigrade research and using these enzymes that make them so indestructible, we created this theoretical idea of a lunar base in which the enzymes from these tardigrades that we would research in microgravity could absorb the radiation in order to make a more cost-effective radiation shield for future lunar bases. And also, it would use the lunar regolith to also keep the price down. And so this is an example of the mission patch that we had for one of those missions. This is a different experiment completely called the WELL mission, which is water exploration on lunar land, where we were going to use that same lunar base to research the ice caps on the moon on both poles. And so continuing with this NASA Scholar Program, I was one of the top performing students in my state, so I was invited to the Space Academy in the summer, in which we basically ran a mock-up NASA mission from the very beginning, and I was appointed as the project manager. And so tying back in with those dinosaurs, they didn't have a space agency to help them with that asteroid crisis. And so my team and I decided to research near-Earth objects and near-Earth asteroids, and how we could use our passion for space and what we know and the data that's available to possibly prevent a future crisis. And so I'm not sure if you're familiar with the Apophis asteroid. It was originally on track to collide with Earth, and it would have been detrimental, but fortunately it's been knocked off of its path, and it's no longer going to hit Earth, but it's going to come super close. So we designed a sounding rocket mission that would launch 2030, 2038, the same year that it's planning to come that close to Earth, to gather data on this asteroid. There's 3 different types of asteroids and how they can be composed. There's carbon, metallic, and silicon. And so we are going to use this data that we collect from this theoretical sounding rocket mission to come up with more efficient ways to prevent near-Earth objects and near-Earth asteroids and to help save our planet. And one of the coolest things we got out of this, we researched the Yarkovsky drift. And it's this theoretical drift that the sun's rays can reach all the way out to the very, very back of space. And it can channel this energy from the sun's rays to essentially destroy the asteroid from the inside out or pull it off of its orbit. And so we kind of designed an object that could harness the powers of the sun and the rays of the sun and use the Yarkovsky drift to pull these asteroids off and prevent these objects from crashing into the Earth. And so also in this NASA Scholar Program, kind of tying in with all of this lunar talk, one of the projects we had was to design a theoretical lunar mock-up base. And so, as you can see, it kind of looks a little bit similar to Iceland with the terrain. And that's what I had in mind, so it's perfect that I'm able to be here and talk about it today. But we had everything from infrastructure to greenhouses, very extreme conditions, even launching platforms. And for example, there's that lunar base with that lunar regolith using that tardigrade enzymes to shield our future astronauts from radiation. And so staying true to this space nerd that I am, through higher orbits, I had the opportunity to attend Space Camp. This is something we have back in the States that's really big among 8th grade to 12th grade, where you basically do almost like an analog mission. You live, eat, and train like an astronaut would. And so here is another picture of astronaut Don Thomas, who I got to cross orbits with again at Space Camp. And he shared more knowledge with me about his 4 different rendezvous to the ISS. I also had the opportunity to attend the International Astronautical Congress, and here I was able to meet with all different figureheads of the space industry from all over the world and kind of pick their brains. And one of the coolest things that came out of this was getting to learn more about this Artemis program and how we're planning to go back to the moon and eventually to Mars. And so I really like how these pictures are set up because it kind of shows the past, present, and future of the space industry. So on this very far right, this is Mr. Mark Kirisic with the Johnson Space Center. And he is the head of Orion, which is the capsule that's going to be taking us back to the moon. And I got to talk to him about what he thinks for the future of the space industry. And he told us that it's young people, it's our generation that's going to be in charge of getting us there and back and to Mars. There's astronaut Wheeler, who was talking a bit about the Apollo missions. And that's my mentor, the awesome Miss Michelle Lucas, who runs Higher Orbits. And she's using her life work as an astronaut trainer and what she's been able to do at NASA to inspire the next generation. And so this is one of my prized possessions. I was able to grab a photo with all of these amazing astronauts. And I want to point out Dr. Jeanette Epps, who's kind of a trailblazer because she's going to be one of the first astronauts on the Boeing Starliner. And so tying in with all of this space exploration, the payload that I showed earlier of our experiment, my team and I were able to travel down to New Mexico to see its launch, but kind of tying back in with what we heard yesterday about the French explorer and how he didn't have very good luck. Our rocket launch was scrubbed, so it hasn't launched yet, but we were able to tour Virgin Galactic's HQ, and you can see Eve, the mothership that's took Sir Richard Branson and his crew up the first time. And so what I kind of want to lead with is inspiring this next generation of future space explorers. Because as you can see in all of these pictures, from all of these presentations and talks I've been able to do, space really inspires everyone. And it's that inspiration that's going to help us to carry out this future exploration, going further into the solar system. And so kind of in honor of my space mom and what she's doing with her life's work, trying to inspire the next generation of space explorers and STEMists, I've created this initiative within my community called STEM Squad that brings these early science learning and early STEM concepts to kids within my community to help also kind of enlighten them with that same passion and curiosity that's been awoken in me for space. And so I want to leave you all with a challenge to share your story as well, because it's those stories that inspire others to pursue after their dreams and pursue after that space exploration. And how we're going to reach the moon and Mars is through STEM, leadership, teamwork, and communication, and all working together, because it's a global effort. It's going to take ESA, NASA, JAXA, the Icelandic Space Agency, everyone working together as a whole to push humanity further than we've ever known. Thank you.
Hi everyone, my name is Adriana Talianova. I am a NASA SEAS intern, a researcher, and an aspiring astronaut with the hopes of walking on Mars one day. However, in order for us to get to Mars, the moon, or for that instance, any other place in the universe, we need to keep our space sustainable and clear, because as soon as our planet starts looking something like this, it's going to become a huge problem, and we can only then dream about going to the moon or any other place we've been to so far. All these small dots are space junk, also called space debris, to which we will get later, and they are now one of the biggest problems we face. But most of you probably didn't consider moving to Mars or going on a vacation to the moon in your lifetime. So why should this concern you? Why is this such a huge issue? Well, let's take it from a perspective of an average person. You wake up, you want to check the weather. But imagine you cannot, because the space debris has created so much trouble. The satellites are down because they've been destroyed by one of the million objects in the universe. And it's not only weather, it's also communications, GPS, and TV broadcasts, and to name a few of the ones we use daily. And while this scenario is not extremely likely to happen, it is essential for us to prevent space debris in order to be able to not only explore the universe, but also to watch our favorite TV show or order a pizza on a Friday evening. And I keep repeating this phrase of making space sustainable, but what does it really mean? It's basically making sure that space remains a place we can use for exploration, communications, everyday use, and for science. And not just now, but also in the many, many years to come. As I already hinted earlier, space debris is one of our biggest problems. It can be anything in lower orbit, from non-functioning satellites to astronauts' gloves, to pieces of paint from rockets. And this is very tightly connected to the orbital overcrowding, as this basically means that there are more and more satellites launched into space every year by companies such as SpaceX or Amazon, and to name a few. And this is one of the main reasons for the amount of pieces in space increasing, and thus just generating more and more space debris, which is now, as we saw in the first picture, all around. Another of our issues, however, is emissions caused by rockets, especially those who use fuel such as kerosene that generates greenhouse gases and soot. And while these are not in enormously large quantities, they still pollute Earth and the atmosphere, as well as the re-entries of rockets and satellites from space back to Earth. And all of these issues have not been discovered today. We knew about them, but the laws on an international level are very, very outdated. And more importantly, most of them, especially regarding space debris, they are not legally binding. So it is voluntarily for companies to follow them, which kind of loses the purpose, since everyone still can do whatever they want. But luckily for us, some of companies has already started working on the solution. So here is a 2018 mission called Remove Debris, and it was a collaboration between different companies, and they tested in real life environment a harpoon, a net using vision-based navigation, as well as a drag sail in a realistic space operational environment. In this diagram, they're explained the use of net. So just very simply, the Remove Debris satellite was deployed from the ISS into orbit by the NanoRay Kyber system. Once it was released in a very, very specific direction, a series of tests started to be performed. In this case specifically, a balloon was targeted at a piece of artificial space debris in order to make it a bigger target. And after that, the satellite released a 5-meter net at the space junk and captured it successfully. This, however, is only the beginning, as in theory this could in the future be able to target space debris up to 2 meters in diameter and up to 2 tons in mass. And this is not the only solution. There are many other missions about to come in the upcoming years. For example, the GeoSpace I mission, which is supported by the ESA with a collaboration with another company, and it is supposed to be launched in the next 3 to 4 years. It will use robotic tentacles to capture space debris and remove a Vespa launcher from ESA's Vega launch in 2013. When this is achieved, the Vespa, as well as the GeoSpace I, will safely burn in atmosphere. However, a very different approach is taken by the Astroscale company, which is using magnetic docking plates in order to capture the space debris, and then they plan on taking it to Earth and then reuse it again, so they are decreasing the cost of removing space debris. And there are many, many other more projects worked around all around the world, so we have hope in removal of space debris. But we also need to face the other issues. uh, there is a need for effective space government, creating unified laws all around the world, and more importantly, making them legally binding. So, making them essentially obligatory to follow. This could be potentially initiated by a United Nations, a worldwide organization, or anything similar, which kind of unites all the countries, and making sure this is not just selected countries or only those participating. And this all depends on the collaboration between nations as well as sectors. The nations, they kind of need to realize it is all affecting them as well. It's not only, it's a worldwide problem. And between sectors, in the recent years, there's been a great increase in private space companies, new companies, SpaceX, Blue Origin, anything else. So we need to make sure these are included, and it's because it's not about only government companies anymore. So this by far is not an easy thing to do, but if we want to call ourselves a space-bearing civilization one day, it is a very, very essential step. Thank you for listening.
So, can you hear me?
Yep. Yes.
Okay, so, hello, my name is Christopher Lyons. I'm in 8th grade, I'm 13 years old, and this is my presentation about studying Viscerum polycephalum, its movement and its behavior, with applications to space. So like I just said, my name is Christopher Lyons. I'm 13 years old. I'm an 8th grade student. I'm from the United States. I'm an aspiring astronaut, outspoken advocate for space and climate education. I'm the 2022 Mars City Design Ambassador. I'm the Inspire 24 Ambassador for Space for All. I'm the creator of the Astro Kids Chronicles collection, and I'm a volunteer for the Florida Fish and Wildlife Conservation Commission. So today I'm delighted to share with you my research that I've been conducting involving Viscerum polycephalum, pertaining to involving its movement, its behavior, and chemotaxis with space application. Viscerum polycephalum, also known as slime mold, is a single cellular organism that has recently caught the attention of many scientists throughout the world. Through its network behavior and ability to find paths to food sources, it has influenced transportation designs in Tokyo and Canada. This brainless organism, it demonstrates a very high level of intelligence and memory, which is extremely fascinating. It has researchers questioning and redefining what actually constitutes intelligence in organisms. While understanding its movements and behaviors on Earth is an emerging area of research, there's a huge opportunity to understand its behavior and movements. Based on microgravity research, we have already know that plants, bacteria, and humans are affected in low-gravity environments. I imagine that Viscerum is no different. I am on a quest to understand how Viscerum behaves both on Earth and in microgravity. And here is a video of it moving around. So, I just read all of this in the previous slides. No, so the purpose of my research, I'm investigating how Fusarium polycephalum propagates, how Fusarium responds to its environment using chemotaxis, and to assess Fusarium's ability to demonstrate intelligence by solving mazes, and also to understand how Fusarium behaves once it is exposed to microgravity. And following this phase of investigation, I intend to do a comparative analysis of Fusarium's behavior on Earth and in microgravity. I conducted a series of investigations recording quantitative and qualitative data. In my first investigation was for slime mold propagation, and the second one for slime mold chemotaxis, and the third one for slime mold behavior, finding out this behavior through mazes and barriers. For the chemotaxis portion, I hypothesized that Fusarium will respond to different chemicals that it is introduced to by moving towards the substance that it prefers. I hypothesize that it will move away from substances it does not want. And in the maze, I believe that the Fusarium will be able to locate the food in the maze, therefore it will successfully complete the maze. I believe that it may be difficult initially for the Fusarium to locate the food in microgravity, as it needs to adapt to the environment first. I believe the growth patterns and rates will differ in microgravity. On Earth, it primarily stays in the diploid plasmodium phase. I believe it may do the opposite and revert to a haploid phase until it adjusts to the microgravity environment. Okay, so this is a high-level step-by-step flow that I used during the investigations. I propagated samples and closely monitored the growth for 3 days. I needed to ensure that I had a viable supply of Fusarium for the duration of my investigations. So for investigation 1, the samples grew extremely fast, far beyond what I expected. The Fusarium began to climb outside of the petri dishes, and they tried to escape out the plastic bags that I put them in. I created plates every 2 days to ensure that I had enough samples to get through all the investigations. According to the literature, slime molds first forage, then branch out to refine the tubular network to optimize for movement and by minimizing the distance between sources of nutrients. And this was very evident. Growth-wise, it responded in an aggressive manner when the petri dishes were placed inside Ziploc bags, which was part of the procedure, despite having an adequate food source. And this is indicated that Fusarium is very sensitive to any change in its environment. And so here is a picture of the Fusarium escaping the petri dish and trying to get out the bag. And so here's investigations 2A and 2B regarding simple oat flake experiments and chemotaxis experiments, substituting with different chemicals. Okay, so the Fusarium located the oat flakes within 12 hours for investigation 2A, and for investigation 2B, I conducted 5 trials, and Fusarium consistently chose the same chemicals that I appeared to prefer, which was cedar oil and glucose, with the exception of trial 4, where it chose salt instead of cedar oil. And so here are some pictures. So this is it with the oat flakes after 12 hours. And for 2B, here's a sample and all the petri dishes that I use. And here are the graphs. You can see that it mainly chose cedar oil and glucose, and it preferred cedar oil the most. And here's the investigation 3A, 3B, and 3C for the maze portion. For 3A and 3B, I monitored the slime over a period of time in 6-hour increments. The slime successfully solved the maze in 30 hours. And 30 hours was the total elapsed time, and it traveled 42 centimeters to find a food. Within 12 hours, Fissarium located both the oat flake and the glucose for 3C. And so here's the picture showing like where the Fissarium started and where it is solving the maze. And for 3C, it located the oat flakes and the glucose within 12 hours. And the additional findings, in one of my petri dishes, I discovered Fissarium in its haploid phase when it's developing sporangia. Following this phase, the sporangia would produce spores which could survive for up to 75 years. Observing Fissarium change phases is rarely seen in lab environments. Clearly, Fissarium is sensitive to its environment. Fissarium has been debated in the scientific taxonomy community. It was once classified in the fungi kingdom. Based on the latest research, it is now classified in the Protista kingdom because it doesn't have chitin in its cell walls and it primarily stays in the diploid phase during the life cycle. In my conclusion, Fissarium polycephalum is truly a fascinating creature that is redefining how we classify intelligence. It demonstrates the ability to decide which chemical it prefers and to travel to that location. It was also able to sense its environment. When in a constrained, sealed environment, Fissarium began to forage beyond its provided food source, perhaps in search of oxygen. It creates trails as it travels, and it does not repeat the same path. For Fissarium to be brainless, this is amazing. And the applications are to algorithms and mathematical models being developed based on Fissarium's movements and mobility in addition to applications in machine learning. It has also been studied within the transportation industries and in the medical field for targeted medicine applications. And to understand how it behaves in microgravity environments has a lot of potential. And Fissarium is optimized to survive and it demonstrates this through the ability to shift so many different forms within its life cycle. As humankind sets out to explore beyond, Fissarium may play a role in this activity. We can learn from its behavior, resilience, and perhaps within the right conditions, utilize it to help explore other planets in the future, or even remote locations on our own planet. Its ability to optimize its resources are amazing. In space, we will have to do this as well. The potential that Fissarium holds is worth exploring beyond the fact that it is an exciting organism to work with. I am hopeful that the discoveries we make, the ones that I hope to make, will benefit the life on Earth and on space. Like humans, Fissarium is an explorer. And here is a simple roadmap of my research, which I plan to continue researching on Earth, suborbital flights, on the ISS, and one day do it on the moon or Mars. And so, here's some previous research projects I've conducted. In 2020, I did a comparative analysis of plant growth on Earth and in space. In 2021, I did a comparative analysis of germ growth on Earth and space. For the past 3 years, I challenged myself to take on a big research project, and I entered it into my school science fair. I used my research to educate, advocate for space and climate change, and to inspire change for others. And so here's my research poster. And my big goals, like I said earlier, to educate, to advocate, and to inspire change. And all that I do is for the benefit of our planet and with the mission to inspire future generations. Ladies and gentlemen, my name is Christopher Lyons, and this concludes my presentation.
you're gonna help me with the video, right?
Yeah, yeah. Which one is yours? Yeah. Yeah, we just click it.
Okay, it's ready.
Hello everyone. Please don't mind my accent first. I'm very poor in English. And I'm Janvi Dangeti. Before introducing myself, today I'm here to share about a little girl who hails from a normal rural town of Andhra Pradesh, India, where, well, I'm sorry, the place where full of religious beliefs and a lot of ancient traditions, full of Mother Nature and a lot of politics. And here you can see a girl of 3 years old where her parents left her just to support her financially to achieve her dreams. And you can also see a little toy there. That toy had played a vital role in her dreams of reaching stars. And she grown up all the way with her grandmother, listening to her bedtime stories about him. She used to tell her a lot of bedtime stories about moon and a lady who lives on moon. And it's in our native language, Telugu, called Chandamama Kadalu, where she used to narrate about a old lady who lives on moon and distribute toys and chocolates to the kids like me. And that sparked interest towards space to that little girl. So, hailing from a town where people doesn't even know the difference between astronomy and astrology, put her into a lot of consequences to find a path to reach her goals. So, that little girl with her mother, who sacrificed her entire life just to support me to achieve my goals, or to her goals, and had that little girl father who made her to stand in a position where she is right now. And when she left her daughter when she was 1 year old, and she came back almost after 9 to 10 years old. That kid couldn't recognize her mother, and she was with a big question mark. Who is she? Even she's coming to her, the little girl. And her father, she doesn't even know that she's having a father. Whenever someone asks a little girl, who is your father and mother, she just reply, my grandmother is my everything or everyone. So it's up to her family. So she grown up as a very mischievous kid. She used to be very active in all her school activities. Of course, there's nothing much related to space, but we used to have, in Indian school, we have a lot of science fairs, which are mostly related to science and technology. So, almost I was very mischievous kid, doesn't even have very good name in my class, but used to get quite good marks. So everyone was participating. That girl was in her 4th grade. So everyone was making big projects and just, it was very busy day. So that little girl was just roaming to every podium to see and learn more about the projects or the presentation were placed. So she got to learn about Apollo missions right there. Up to then, she doesn't even know that people go to space or moon. But whenever people ask the little girl, what do you want to become in the future? She used to just reply that she'll go to moon one day just by using the toy plane, and she'll stay there and she'll collect those toys and chocolates from that old lady. And that's the point where she realized, yes, people actually go to space using rockets. NASA sent them. So after 6 to 7 years, when I was in my 8th grade, my school have conducted a very big
science fair, which includes Limca Book of Records and Indian Book of Records, and also Telugu Book of Records. So everyone was chosen by the teacher, but that little girl was not chosen by anyone because she's not good in her mathematics. So only top 3 students were taken, and I'm not in the top 3. So that girl is not in the top 3. So we didn't get selected. So that girl started doing her own project, where she won Telugu Book of Records for being very young and doing her own project for the very first time. So that's the point where she realized, apart from support and everything, we should believe in ourselves. And then she started doing her own research using internet and everything. Of course, even then, she don't even know where to start her journey to reach space or stars. And then, after my 10th class, in India, we have public examinations in our 10th grade. If we doesn't qualify, we couldn't pursue our 11th or 12th grade. We should qualify our 10th, and she completed her 10th grade, and she moved to 11th, and in her 12th, she got a life-changing opportunity, which is she got to know that she'd been selected for a project which is called ISRO World Space Week, which was organized by Indian Space Research Organization for the event called World Space Week. So she and her friend, who is also a space nerd, decided to take part in this event and present their work, which they are working since 2 years. Of course, it's a very common project. You might have all heard about ionic propulsions and ionic propellants. So as a very young minds with no proper support in such small town, people were so surprised to see our work and the things we try to develop artificially just to let the people understand what exactly ionic propulsion is. So there, among 2,000 projects, right from 8th grade to PhD, we won, that little girl and the boy won first place among all the 2,000 projects. And that where she realized opportunities doesn't come to us. We should run behind them, because the world is very much competitive for everything, right from single thing to the big ones. Everyone is just running behind the opportunities. So that's where she's receiving ISRO World Space Week Award from one of the major ISRO directors. And yeah, apart from her journey, let's come to her statistics, where why Indian women, I don't mention all the Indian women, but mainly in my place, why it is so hard to achieve a dream just by coming. It is really hard to step out of our comfort zone. It's because the first one is inequality. One of the major concerns are inequality. It causes the gender, what should I say, apart from the job and the thing, lack of awareness among women about their rights and their ability to achieve equality. And along with that, there is a lot of social pressures and ancient traditions which makes women to get married at their very early age. I don't know how many of you will believe this, but many of my classmates were already married, and few of them are already having kids. At the age of 18 to 20, we actually start our life to understand. We start learning about ourselves, but there, it's not like that. We'll be getting married to a person whom we don't even know them, with whom we never talked to before. So you can see by age 22, more than half of women in Andhra Pradesh stay at home or married. And very few women are allowed to go out of their home and to work or to study even after getting married. Most of them are meant to sit at home without doing anything, just by sacrificing all their dreams because of parents'
beliefs or the traditions which they are following. In the same way, when that girl have done with her 12th grade and started learning about the world, she had to face a lot from society and as well from the family to drop her dreams and to settle down with a normal life. I don't know, I'm very fortunate that I can proudly say that that little girl parents never let her to stop her dreams or break her wings, because they keep supporting her in all the way they can. And yes, of course, I was hospitalized. The little girl was hospitalized for more than 6 months just because the fear that she couldn't achieve her dreams. But later, that girl decided to start doing just by coming out of the comfort zone. At that time, I met really beautiful people who supported me. One among them is Sophia and Zara and many more. I have 2 common who have already been here. So I started building very good network who are having very similar interest in this field and started learning more about them. And I took a step forward. Apart from this research and everything, I started doing my own practice of becoming an astronaut. Because in India, the astronaut trainings are not yet ready. So they are still in the process. You might heard about Gaganyaan. So I started doing my scuba diving course. When I asked my parents that I want to start my scuba journey, they were so shocked, and they're not really ready to send me because they are, of course, they are also an Indian parents. So I somehow let them understand why it is very much important to have this license. And this was my very first swimming class. So in my entire life, I could remember the guy, Subhash Chandran, who played a very major role. Me, I don't even know swimming. He made me to believe just by saying a single line, great things always take time. Just believe in yourself, stay calm, and do it. So I started learning swimming from him, and then I did my open water scuba diving course in Goa. Along with the process, he's also an ocean cleaner. He made a lot of ocean cleanup sessions with Parley of Oceans and Platypus Escapes. So I started doing ocean cleanup along with him, and he started creating a very good interest in me about marine life. So I decided to do my advanced course. So I did my advanced course in Andaman and Nicobar Islands. So I'm the one of the youngest advanced adventure scuba divers of SSI Scuba Schools of International India. So I achieved my license as well. And then you can see right there, that's my very, very first work with NASA, which is actually related to space, where I've participated in an asteroid search campaign. And then in between, actually these are the major one I'm representing, but I've also participated in NASA Space Up Hackathon, where we won NASA People Choice Award and many such projects. After coming back from Andaman and Nicobar Islands, this girl got to know that she been appreciated by Indian Book of Records for being a multi-talented girl. As I've mentioned, I've been active in all my school days. I've also been to a karate international level and won silver medal right there. So for all the works, the Indian Book of Records appreciated me by giving a title called Multi-Talented Girl. And this, the main part of my entire journey. An year ago, I've applied for NASA EXA program, which was held by a Mexican company. They choose 60 students around the world who are into this space and who wants to pursue their dreams and career in space and technology. So when I've applied, I got welcome letter from the EXA, and I'm the very first Indian to get selected for this program since 20 years. So that's my picture representing my India proudly for the first time. And then me, don't believe me or not, I always want to sit in a cockpit, but I never thought I'll get an opportunity at very young age. I got to sit with my co-pilot Joseph in Cessna 172. We had some ground classes like 2 hours. They taught us the basic functioning of Cessna and the craft. So that's the picture. And that little girl who always watched videos about astronauts and scientists on internet, finally she met an astronaut who's Ken Cameron, where her dream turned reality. I couldn't control my tears out there. I was crying and weeping, and he was so nice. He explained me where to start and how to be like. He gave me a lot of guidance to achieve something, not something, anything. And then, right after coming back from the program, after 6 months, I've seen people who do analog machines, one in Brazil, in Switzerland, and many other. But I got an email from Agatha saying that I've been selected for their analog training as youngest foreign analog astronaut in Poland. And that's my mission. And she's Eamon, and he's Evandros, Alexia, again Alexis, and he's Jacob, and this is Janvi. And we are all from different states. This is our very first day. We did, we had 2 survival tests, and this was one of the most interesting one because we had to be in very cold water and they keep on asking different questions. Mentally, we can't just lie to them. It was one of the best experiences I ever had. Oh, the video. Yeah. I had taken part in lunar base mission, and this is our very first breakfast in the habitat. So we were just having some discussions about what to do on the day. Yeah. Yeah. Here, actually, the video got stuck. I had a plan in my mind to work on hydroponics during my analog mission, but unfortunately, I didn't find all the instruments that are needed for the project. So I decided to start doing something unique. Using, apart from cocoa pit, I want to try cat straw as a seed germination base. So I started doing it, and you don't believe me, the results were really good. It is more good and efficient when compared to cocoa pit. Yeah, and that's our habitat. Here me while receiving my degree as an analog astronaut, and this is the observatory of a Polish astronomer called Bogdan. He's the most amazing guy you can ever find. Of course he's in his 90s, but he's still very much active, just like kid. And he gave me one of the best books. And this pen, which I'm holding right there, was used by an Apollo astronaut, Alfred, and that's also one of my best moments. And yeah, that little girl is this, Janvi, and I'm Janvi. Currently pursuing my bachelor's degree in 3rd year from Lovely Professional University, Punjab, and a part-time degree in psychology from Asian University of Taiwan. Doing my analog machines and also working as a citizen scientist and also doing some projects with this. yeah, that's it. That's all about me. I just want to share a video of our analog machine. Yeah.
Gagarin był pierwszym człowiekiem w kosmosie. W kwietniu 1961 roku spędził na orbicie blisko 2 godziny, ale tak naprawdę wszystko zaczęło się 16 lipca 1969 roku na przylądku Canaveral. Po 4 dniach Neil Armstrong powiedział: orzeł wylądował. 20 lipca misja Apollo 11 dotarła na Księżyc. 6 godzin później dowódca misji powiedział:
It's one small step for man.
Od tamtej chwili kosmos stał się marzeniem i nadzieją ludzkości. Do gwiazd latamy regularnie i ciągle w nie spoglądamy. Na południu Polski jest obserwatorium astronomiczne, a to załoga misji kosmicznej, która przez tydzień będzie żyć dokładnie tak, jakby żyła w kosmosie. Polak, Indyjka, Amerykanin, Tunezyjka, Cypryjka i Cypryjczyk zaczynają właśnie swoją księżycową misję Astra 45. Wrócimy tu za tydzień.
Nazywam się Agata Kołodziejczyk, zbudowałam pierwszą w Polsce bazę kosmiczną.
Niedaleko stąd istnieje baza kosmiczna, o której mówi dr Agata. Miejsce, w którym panują warunki takie jak w bazach i stacjach poza Ziemią. Bazy nie ma na mapach, jest ukryta, z dala od cywilizacji. Z dr Agatą spotykamy się przed północą na rozstaju polnych dróg. Prowadzi nas na miejsce. Byłem już w wielu niezwykłych miejscach. Bazy kosmicznej na Ziemi nie potrafię sobie wyobrazić, ale przecież nie może to być nic nadzwyczajnego. Jak bardzo się myliłem. Załoga misji Astra 45 spędziła tu tydzień w całkowitej izolacji. Wchodzimy.
Hello. Hello, my name is Andros. I'm the communication officer. You are now in our habitat. Please come inside and we can meet you the whole crew.
Centrum kontroli misji oddalone jest o kilkadziesiąt kilometrów. Załoga monitorowana jest 24 godziny na dobę. Wszędzie są kamery i czujniki. Nie ma dużo miejsca. Niewielka kabina sypialna z piętrowymi łóżkami. Centralna część też nie jest duża. Poza tym jest tu jeszcze siłownia i toaleta. Nie ma wanny ani kabiny prysznicowej.
Oni się myją tym.
Na Międzynarodowej Stacji Kosmicznej też nie można się wykąpać. Doktor Agata wyjaśnia, że załoga ma zaplanowany każdy dzień. Misja ma do wykonania wiele zadań i eksperymentów naukowych. Zamknięci tu ludzie nie wiedzą, czy jest dzień, czy noc, która jest godzina. Stracili poczucie czasu.
Obudziliśmy się 10 godzin temu, natomiast przez ostatnie 50 godzin spałem może 3 godziny.
Czyli dziś, teraz w tej chwili, która jest godzina? Jak
Teraz?
tam na zewnątrz, tak. Strzelaj.
Wow. Na zewnątrz kompletnie nie mam pojęcia, szczerze mówiąc. Tak po wyczuciu, po tym jak się czuję, jakbym się czuł na zewnątrz, mógłbym powiedzieć, że jest 12. Dzięki właśnie tym energetycznym drzemkom.
12 w dzień.
12 w dzień.
Misja Astra 45 po wielu dniach znów spotyka się z Agatą. To ona wysłała ich w kosmos, to ona spełniła ich marzenia. Emocje są ogromne. Łzy szczęścia muszą trafić do próbówki. To jeden z eksperymentów.
Collect tears! Collect tears! Tears!
It's over here.
Nice to see you!
Życie toczy się tu od zadania do zadania, od eksperymentu do kolejnego raportu. Załoga hoduje w bazie rośliny, produkuje wodę z moczu, testuje działanie kombuczy. To śmierdzący grzyb, z którym przemysł kosmiczny wiąże ogromne nadzieje.
New kombucha, new type of kombucha you designed.
Not designed, but it was swimming,
How
but
it
it's
smells?
just already floating in the.
It's a
yeah,
sulfur.
It's basically it's not kombucha. It's a
Did you measure
no.
ions?
Kiedy mamy opuścić księżycową bazę, nagle dochodzi do burzy magnetycznej. To scenariusz zaplanowany przez Centrum Kontroli. Załoga sprawdza, jak radzi sobie w sytuacji kryzysowej.
Everyone, emergency! Emergency! Radiation coming in 15 minutes. Get the suits, let's seal up the thing, get food and water in the shelter, and get medical devices. Yada, let's go! Next, yeah, turn on all power.
Up, faster!
Yala, get on the ground! Radiation's coming soon! Crawl to the door! Everyone put on your suits. Alright, Janu, you and me will seal the door. Get as low as you can. Crew check. Iman?
Yes, sir.
Janu?
Yes, sir.
Ivandros? Yes, sir. Alexia?
Yes.
Przed 2 w nocy zostawiamy załogę Astra 45 w habitacie, żeby za kilka godzin tu wrócić. Wtedy znowu zobaczą słońce i bociany.
Uratowani jesteśmy! Bocian! Patrz! Bocian! Jak on żyje, to znaczy, że my też możemy!
Z załogą Astra 45 wracamy do obserwatorium astronomicznego. To tutaj opowiedzą nam, po co zamknęli się w kosmicznym habitacie, jakie mają plany i marzenia, jak zapamiętają swoją misję i po co dr Agata Kołodziejczyk zbudowała pierwszą w Polsce analogową bazę kosmiczną.
I want to become an astronaut. This is the goal of my life.
Jako Polska jesteśmy, można powiedzieć, pionierami w Europie, jeśli chodzi o takie treningi. Ludzi, którzy w przyszłości myślą o tym, żeby polecieć w kosmos.
So 2 months ago I started researching. I found AATC online, applied, and within 2 days I got a response back from Dr. Agata saying I'm more than welcome to join for this upcoming mission.
I got invitation from AATC. It's like a life-changing moment for me.
To są osoby, które nie boją się nowych rzeczy, nie boją się opuszczania strefy komfortu. Są to osoby, które chcą spróbować czegoś nowego.
It was a very weird week. I mean, all the isolation, I forgot how the real life is. It was something weird for me, something new.
Trudno jest się przyzwyczaić do czegoś takiego, do szumu wentylatorów, które cały czas chodzą, do temperatury, która tam panowała, do tego, że się śpi z 5 innymi osobami, które łatwo mogą przeszkodzić Ci w spaniu.
The isolation, we are not under the sun for 8 days. We get used to the LED ultraviolet lights. Let's say 90% I felt like I'm in space, especially that we wake up, we eat, we do our measurements, we go to our experiments. It's like this constantly, and we never say no, we never quit. It was pleasurable.
It's really a big deal of time management, where we learned really well here.
Cały ten czas spędzając tam czułeś się, jakby to był jedyny świat, jaki Cię otacza.
I was trying to be as positive and as productive as I could. I was trying to manage this pressure into productiveness.
Podstawą tej działalności jest nie tylko jakby taka działalność stricte personalna, dedykowana dla tych osób, które się zgłaszają, ale chcemy podzielić się tymi wszystkimi wynikami, które tu generujemy z wszystkimi.
Because I was a communication officer, I had to do a report about what happened every day, what was everybody's feeling, mood, progression and everything. So I had to stay a little bit more after everybody was sleeping.
Mieliśmy określoną dietę i musiałem się jej trzymać. Musiałem się jej trzymać, bo inaczej musiałbym pisać cały raport, dlaczego mam takie, a nie inne wybory i co dokładnie zjadłem, ile kalorii, ile gram.
To make the robot to work, it was so. When I first operated him, I just started screaming. It was a unique moment.
My goal is to be a doctor in space, either in a space station or by the time I'm out of medical school, maybe we have a station on the moon. First aspect of space medicine is studying how the body changes in space, in zero gravity, in exposure to cosmic radiation from the sun or other bodies in space. So it's kind of adapting to this new environment.
My tam kontrolujemy wszystko. Żaden szpital, żadne więzienie, żadna izolacja w celi nie generuje takich danych, jak generujemy my w Habitacie. I bardzo się cieszę, że coraz więcej osób z dziedziny psychologii, neurobiologii, z dziedziny dietetyki, z dziedziny sportu przychodzi do nas i pyta, czy może przeprowadzić badania w warunkach izolowanych, w warunkach kontrolowanych. Jak na przykład symulujemy podwyższone stężenie dwutlenku węgla, bardzo taką ciasną przestrzeń, dużo osób, bo 6 osób na 57 metrach kwadratowych to jest to, zwłaszcza jak się nie zna osób, to może być troszeczkę męczące dla osób, które przyzwyczajone są do pewnej prywatności.
We had an emergency and we all worked together as a team, like automatically. We were like robots, knowing what to do, and we had no idea how to do it before.
Because at the end of the day, yes, you do need smart minds to come together and have a successful mission, but having a good team dynamic goes such a far way, such a long way in making sure that the mission is a success. And I think my team, we had a great dynamic. We all supported each other. We were all there for each other, and I wouldn't have wanted it any other way.
I'm happy to share that my state government is going to fund me for my entire flight training and every training I'm going to do. Thank you. Thanks so much.
Listen, I just wanted to say thank you very much, Genevieve, Adriana, Chris, Sophia. I mean, all of you, you're absolutely amazing. And Chris, you said you wanted to inspire future generations. Well, you've inspired past generations here too. And so, and now you're all going to have a space quiz. So I'd like you up, Chris, Genevieve, Sophia, Adriana, up here, please. Get on the stage. Can we go? Should we go on the stage, Orly? Is that the best thing? We have a little space quiz for you, because we need to know more about you, because we've talked about space travelers, astronauts, cosmonauts, space scientists. All of these guys are going to join. So I'm going to ask you a series of questions, and you have 15 seconds to answer, okay? And first of all, we have a couple of questions. I'm going to ask you all, who is your space hero and why? Take the microphone, speak into it, pass it along.
Okay, my space hero is Dr. Michaela Musilova. And yeah, she's a Slovak, so it's a very small country, and she's the first woman from Slovakia possibly to fly to space in the future.
My space hero is my space mom, Miss Michelle Lucas. She always dreamed of being an astronaut. She wasn't able to go, but she didn't let that stop her from sharing her passion about space for everyone, with everyone.
My space hero is Kalpana Chawla, who is the first Indian woman to fly into space, representing India as an Indo-American.
My space hero is my mother, because she's the one that got me into the space realm, and she's the one that's helped me all the way through.
Thank you very much. Who also works at NASA, by the way. She's going to be taking questions later on. You didn't realize that. Okay, tell me what you think is going to be, when you go into space, because I know all of you are going to be going into space, you only have 20 seconds, so think about this carefully. What is going to be the most challenging aspect of being in space for you?
Well, I hope when I will be going to space, we'll be going to Mars. So I would say that trying to live on a planet we've never been before.
I definitely agree with that. And being on a new terrain, I think I'd miss Earth a lot.
Well, balancing mental and physical pressure.
Okay, so I agree with basically what the rest of you said, basically, with especially missing Earth and everything.
I'm going to miss swimming when I get sent into space. I won't be able to swim in space. Okay. Now, we know that at the moment on the International Space Station, which has been in orbit since 1999, it's been inhabited since the year 2000, I think I'm right in saying, and every 6 to 8 weeks, correct me from the audience if I'm wrong, you get a shipment of food coming up, supplies. Sometimes it's a Russian shipment. Sometimes it comes from the States. So, and the astronauts can request their favorite food. So when you are in space and even Mars, on your way to Mars, and you want us to send your favorite food, I want to know what you want to eat in space.
I think this will not make them happy, but I would want sushi.
I agree with the sushi and all types of pasta.
All the Indian food, mainly biryani.
I probably have to say pizza since that's my favorite food.
Well, I think that Chris, you probably know this famous video of the astronauts having a pizza night in space. Okay, so I can imagine the pizza is a little bit better than the sushi. All right, you get to do, what is going to be your favorite experiment? I think I'm going to know what your answer is, Chris, but tell me the favorite experiment, because as we know, the ISS, and before that, the Space Shuttle, and on Mars, there's going to be a lab on Mars. We would imagine that's going to be set up. It's certainly going to be part of the Artemis base. So what is the one experiment that you are getting ready to do and that you want to do and you think would be the most valuable?
I would say searching for life and water on Mars, microorganisms.
I agree, and tying in with that, maybe researching the ice caps that are on both ends of Mars and seeing if there's any bacteria or extremophiles there.
As of now, with my experience till now, I would like to learn more about mental pressures, how astronauts handle over there, and solutions for the pressures. And maybe I might change my experiments or projects by learning experiences.
So what I would do my experiments on is the Viscerum polycephalum, like I did with my presentation earlier.
Yes. Thank you very much. And finally, science fiction films. I want to know your favorite science fiction film.
Interstellar or The Martian?
Those are very good. Star Wars.
Gravity.
Probably Star Trek.
Okay. I think you're all incredibly inspiring, and I am looking forward to all of you in space. I want to see your experiments, and I want to hear what you have to say when you return. Thank you so much. You've really inspired us.
Thank you.